Hello, in this video we will talk about the properties of OLS estimators in linear regression. So OLS means ordinary least squares estimators for linear regression model. So after we have estimated a linear regression model, we get beta 1 and beta 2, but this form can also be written as y mean value equals beta 1 hat plus beta 2 hat times x mean value. So which means the regression line passes through the mean value of x and y. So this is a point, means the actual opposite of the values for the y, between y and x, and this point is the mean value of x and mean value of y, so cross at this point. And this is the regression line. Then this line, this is the normal regression line. We can write as the y observations equals x times beta 2 hat plus beta 1 hat. So this is estimated y value from the parameters estimators. And this line passes through the mean value between x and y. The next property is the mean value of y is equal to the mean value of the actual y. So this is the estimated value of y. If we look back, so on this line, odd y value is the estimated y value. So we can write as y hat. So this is y hat I with corresponding to each xi value, right? So this is the estimated y value. So estimated y value can be written as this expression, and because beta 1 hat equals y mean value minus beta 2 hat times x bar. So this expression is during the estimation process. So we have this relationship, these two relationship. Then we use this one and plus beta 2 hat xi. Then you can see beta, so y, each y observation based on the estimation equals the mean value of y plus beta 2 hat. This is the parameters estimated times xi minus mean of xi. Then we sum together for both sides. So this is all y values summation, and this is all summation, and because this one summation will be washed out, right? Because x sum of xi, then we divide it by n, this will be washed out and only left with the mean value of summation of yi hat and the mean value of y bar. So this way can reduce to the mean value of the estimated y value equals the mean value of the observed y value. And the next property is the mean value of the residuals. Can write as ui hat is 0. So during the estimation process, this is one of the normal equations. Sigma yi minus beta 1 hat minus beta 2 hat times xi equals 0. And actually this part equals the residue ui hat. So if we look at this figure, well, what is the residue? Residue is between the observation is the real y value and estimated y value. If we, for example, look at this point, so the difference, the vertical difference between this point and the point on this estimation line is the residue ui, right? So this is also ui, different ui, and for this one the ui is negative and this is positive ui, right? So the ui equals this one, and because this equation is 0, then we can get minus 2 times the sigma of ui hat equals 0. So which means we can divide by n and we can get the mean value of the mean value of the residue is 0. So for example, so we look at this figure again. So although you can see the residue can be positive or negative, but the mean value, we sum together all the residues and divide it by the number of observations, we'll get a 0. And the next property is that OLS estimation can also be expressed as a deviation form. So what is deviation form? Because we get the y value equals the estimation of y value plus a residue, and this OLS line also passes through between the mean value of x and the mean value of y. This is one of the properties we have introduced, right? Then we make a subtraction. So subtraction this one from this one. We can get yi minus y bar equals beta 2 hat times xi minus x bar, because there is a beta 2 hat in common, right? And plus ui hat. So this part we can expressed as lowercase yi, which means the deviation form. So this is the yi minus the mean value of y, and this also can be written as a deviation form, which is xi minus x bar, which is the mean of x. So this is also lowercase xi, then plus a residue. If we look at this figure, so what is the deviation? Deviation is observed y. This is the mean value y. So between this point, for example, and this line. So this is the mean value of y. This is the deviation between y and y bar. Y bar is the mean value of y. And for the x, also this point, deviation of x is this point x value minus x mean value right here. So this is the deviation. And for the other points, similarly, this is the deviation for the y, and this is the deviation for the x, right? So for the deviation form, because we can write as this one. This is the actual y value, and after estimation, we can write as the yi hat equals beta 2 hat times xi. So for the xi is deviation between x and the mean value, and for the yi hat deviation is estimate the y value minus the mean value of y, right? So you can see in the deviation form's OLS estimation line, there is no beta 1 hat, only beta 2 hat here, right? For not deviation form, there's one beta 1 hat here. But for the deviation form, because it's a deviation between the y hat and the mean value of y, so the beta 1 hat parameter is washed out. And the next form for the property is residues are uncorrelated with the predicted y. Here is a predicted y, so it's a y hat. Okay, so we can write this form. This is actually the correlation calculation for the definition, because correlation is the deviation from y and y hat and its mean value, and this is also for the residues to its mean value, because the mean value of the residue is 0. So actually, this is the main part of the correlation, right? Then we can write as this one, because this is deviation, so we can write beta 2 hat times xi is also deviation. then we can express residue as the yi hat minus beta 2 hat times xi. So because here is not a hat, it's is the deviation between the actual y and the y mean value, right? So this is the residue part. Then we can also take out each part from this summation, and from this part is the beta 2 hat estimation form. We can fill in this form and we'll get beta 2 hat square times xi square. Then this division will be 0. So which means the correlation between y hat and ui hat is 0. Okay, this is the double page. We have, the same result as the last one. And the next property is that residues also uncorrelated with the predicted I. So predicted I is also the actual xi, right? So which means this is not predicted xi. Sorry, we have no predicted I, it's only xi. So this is a written fail. Just repeat. The residues ui are uncorrelated with xi. So xi is explanatory variable, so which means the residue is uncorrelated with explanatory variable. So this form is 0. So this is not difficult to prove, because during estimation of the parameter, you can easily get this form, right? So thanks for watching.